So today, here you'll be learning from me how to name alkynes. As you know alkynes, this molecule must contain carbon-carbon triple bond, this functional group. So one example that you know is an alkyne would be when you see something like this. 3 lines of equal length. As you've learned from me, it must end with carbon atoms, so for this molecule in this skeleton structure, it represents a 2-carbon alkyne. And as we know 2-carbon, you must have the prefix of "-ate". Remember? And since we know that it is an alkyne functional group, we just put ethyne. And this is synonymous to C triple bond, and the carbon at the terminal end has an H. Which means the formula for this molecule will be C2H2. Now let's revise what is the degree of unsaturation for this molecule. We see no rings, but 2 pi bonds here. That means the degree is 2. 2 degrees of unsaturation. And let's verify it using the formula. Suppose you have a 2-carbon alkane. We would have the formula of C2H6. So now we take 6 minus 2, the number of hydrogens that we have, and divide by 2. Indeed, we have 2, and it matches up. Next molecule with the alkyne functional group here looks like this. Now first look, count the number of atoms. 1, 2, 3, 4. So this must be a form of butane. Okay. But the thing is, I could also draw isomers of butane that also has 4 carbon and with a triple bond. Maybe like this. You see? 1, 2, 3, 4. So how are we able to distinguish these 2 formulas by just saying butane? We can't, because they're isomers. So we have to label exactly where is the triple bond. Now for this case, the triple bond occurs between the first and the second carbon. So we call this 1-butane, or you can say but-1-ine, right? Because it's between the first and the second atom. You might ask, why don't we count from the other end? Because you have learned that if you count from the other end, that would be 1, 2, 3, 4. Then we will have a but-3-ine. And now that we have a choice, we always go for the smaller number. For this molecule at the bottom, if you go from either side, you reach 1, 2, 3, 4 or 1, 2, 3, 4. Again, this is symmetrical. This triple bond is between the second and the third carbon. So there's only one name for this, which is 2-butane, or you can call it but-2-ine. So you see that the difference between these 2 names for the isomers is only the number here. And this tells you clearly where exactly the carbon-carbon triple bond is. Now for last practice, let's do something more interesting. Right. Now we have a methyl group here, but this does not belong to the longest chain. So again, the longest chain, we count 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. So they are the same. You can go either way at this branch. But anyhow, our longest chain here would not include one of these methyl group. Now the thing is, do we start from this side as 1, 2, 3, 4, 5, 6, or that way 1, 2, 3, 4, 5, 6? The answer is very clear. This is the main functional group of a high priority here, so we must have the smaller number for this triple bond, which means it must be a 1, 2, 3, 4, 5, 6. Okay? And we have a methyl substituent here, so the overall name will be 5-methyl 2-butane. Oh, pardon. There are 6 of them, so it's not a but, that's right, it's hex. 6 is hex. So 5-methyl 2-hexane. Right. So try to practice more on the naming of alkyne.